Hi everyone, my name is David Daou and I work for the United Nations University, and today I'm going to present AI in the environment and climate change, the cost, regulations, applications and benefits. The first thing that comes on our mind when we think of AI is we need fast computers, we need database infrastructures, but also we need mines and metals. And all of those, each one of them causes a different environmental problem. So take the computers and consume lots of energy. The data infrastructure are causing lots of CO2 emissions. The mines are polluting the water systems, but also causing damages to the health of people. Some reports showed that these people can inhale some products, and this can in turn cause some lung cancer. So to give just an example of these elements, I take the selenium that is used for battery technology, the gallium in semiconductors, the indium in computer chips and screens, and then the hafnium that is used in integrated microprocessor circuits. So to move now to another aspect, so in terms of demand in energy, so the data centers today, they use around 200 terawatt per hour. The estimation in 2040 is like they will need twice as much as the global electricity demand on Earth. If we move to emissions of CO2, so a car, on average, during its lifetime, can use 126,000 of CO2 emission. Compared to trained model in GPU, like if we take an example of transformer with neural network architecture, then we realize that compared to the car, the CO2 emission is around 5 times more. Now, another type of pollution that is caused by the data centers, what they call the cooling towers, they have used them to actually evaporate water and then drive the cooling of air. This in terms have caused the use of 100 billion liters of water per year by these data centers. Now, today's, of course, we have other solutions that will help in this sense. So if we take the CO2 equivalent emissions in a machine learning model today, and I compare it to a car average, including fuel, it's like 10 times more, as the car average is around 60 tons, while the machine learning is around 500. And here I'm talking only about the GPT-3. So imagine if we were talking about like GPT-4 or the next generation of GPT. So now, based on all what I have presented, we need rules and regulation, but these rules, they exist in some countries, but they are not binding yet. But by the time these rules become binding, then the developer will find another solution, and we are not able to follow them with our rules and regulations because we are very slow. So we are somehow disconnected from reality. And then, as you can see in the graph, we are turning in different directions. So we need to find a solution for that. One of the solutions would be to create committees that are fast in implementing rules and regulation. Now, let's forget the negative impacts of AI and focus a bit on the positive impacts. So AI is very important today. It's helping a lot in adaptation measures and prediction when it comes to environment mitigation and adaptation. AI is helping in creating solutions to complex systems which we didn't manage before the existing of AI. It's also improving the early warning systems. It's helping in atmospheric and Earth observation, in detecting floods, droughts, aerosols, and clouds. Also in detecting plastics, ships, and storms or heat waves. I will give some examples about AI. At UNU, we are using the neural network and machine learning to improve the detection of flood and drought. There are other people who are using AI models for climate and weather forecast. And then these models, eventually, they are not perfect, but at least they agree with classical models in short-term forecast. Now, some of the applications of AI, like we are using AI to have more energy efficient buildings. We are using AI for CO2 removal, for monitoring coal plant emissions globally by automating the analysis of images of power plants and checking if there are new power plants that are being built. Better calculations, for example, of the premium after a hazard happened, like say hurricanes that hit an island, then this will allow us to fast calculate the premiums and generate payout in near real time. So these are examples. Now I want to talk about some things we are doing at UNU. Like this map is in Addis Ababa in Ethiopia, and we were trying to do a classification of vegetation, urban, bare, water in the capital. And basically we used first machine learning, like the card or the SVM, and then or random forest. What you see in front of you is actually the card, but we also used neural network. And then we managed to get around 76% of accuracy. Another example, like to be able to identify using a LiDAR in the atmosphere, the small non-precipitating ice crystal, we call them TIC1, and the large and precipitating ice crystals, we call them TIC2. So imagine now you have TIC1 and TIC2 together. How can we separate them? The classical ways of separating them, they didn't give a satisfactory result. So basically now we are using AI, which is much better than the classical methods. Now, one last thing I want to talk about is we noticed that the costs are huge, and then to have some kind of fair AI between global north and the global south, we need to have to transfer the knowledge in from the north to the south, but also once this knowledge is there, we will benefit from it because they have their own ways of seeing things, and then they have also their own values. And like this, we create a more fair and more justice in the world. One last thing, AI is good and bad. So it all depends on the user and developer, and AI will always be here. So we need to live with it and we need to adapt. We don't want to stop it or halt it. Another thing, so we can propose lots of solution in this sense. So efficient and quick scientific committees for creating rules and regulation for ethical AI, funding to spread equal opportunities all over the planet, use the heat that comes from hyperscale data centers to heat regions or close neighborhood through pipes. So like this, the energy doesn't go unused, and then remove all the servers of small data centers, move them to hyperscale facilities to reduce consumptions of electricity, carbon footprints, and drop in energy use. Turn off the servers that are idle or reduce the number of servers that are on during low traffic hours. Move hyperscale data centers to cool or cold areas by blowing outside air into them and using pipe water to produce and recycle the cooling system. That's it from my side. I want to thank you all, and I'm here if you have any questions.